Welcome. My name is Whitney Lee. I'm a developer advocate, and I'm here with Michelle. Michelle, will you introduce yourself, please?
Hi, everyone. Nice to meet you all. I'm Michelle Nguyen, and I am a maintainer of the Pixie project. This is a CNCF sandbox project that I'm very happy to be a part of.
We're going to learn about Pixie today. I'm so excited. So this board is already chock full of information about Pixie because Michelle and I just spent the last hour and a half together having a conversation about Pixie where Michelle taught me all of this stuff. And now we're going to do a recap video and teach it to you in less than an hour and a half, some amount of time less. So before we get started and dig in on Pixie, which I'm so excited about, what I want to know is what was the world like before Pixie? Like what problem is Pixie solving?
The world before Pixie was kind of this point where a lot of people were beginning to shift towards building their applications on distributed microservices. So this is kind of, when Kubernetes itself started getting really popular and people started running into issues where it was just really hard to understand what was going on in their systems. Like, how does this service talk to this other service? You just have so many different services that are split up within your application. And it's also very, very tedious as well. In order to start collecting data, you have to go in and instrument your code, make sure that you capture all the different places that you might want information from. And that's not always the easiest, especially in large organizations and teams that may not always follow the same conventions.
Yeah, when you have an application that's been running forever, you're like, oh, I don't want to change that at all. That makes so much sense to me. How does Pixie fit into this problem? How does Pixie help solve this problem of observability being hard and tedious?
Pixie is an observability tool that helps you collect a bunch of information from your cluster, and we'll dive into some more about, what that information could possibly be without you having to go and instrument your code. So, all you have to do is deploy Pixie, you keep your application running, and Pixie collects a bunch of information for you without you having to do any work besides just deploying Pixie.
That is so cool and it feels kind of magical. But one thing I really do want to understand is like when you say like lots of information, what do you mean? Like what information is it collecting exactly?
Pixie collects a lot of standard metrics that people may be familiar with, things like resource metrics, like, how much CPU is this pod consuming? How much memory am I using? Metrics for understanding how are you reading and writing to files in your pod, or things like network metrics. So like how many bytes are being transmitted or received by this particular pod? How many TCP drops are there on the network? One place where Pixie really shines is its protocol tracing. So Pixie is able to collect information about all the network traffic that's happening inside your cluster. So from, individual requests from this pod is making this HTTP request to another pod, you're able to see all the information, like when did that happen, who is talking to who, the actual full body responses and request bodies in those messages. Pixie is able to do it for a bunch of different protocols in your cluster, such as HTTP, database traffic, Kafka, Redis, for example. And finally, the last thing that Pixie collects is application CPU profiles. It's kind of a way to understand, where your application is spending its time. So like which function is my application spending the most time in order to serve my requests. And so that helps you go in and debug, pieces of your code that might be particularly inefficient.
This is such a different take on observability. Before today, I'd only ever talked about observability through the lens of logs, metrics, and traces. Maybe instrumenting your application to collect those things, maybe adding extra tools to your cluster to collect those things at the cluster level. And this is something completely different. Does Pixie replace the more traditional kind of observability instrumentation? Is it instead of or in addition to?
So Pixie, we like to say it's in addition to. At the end of the day, we say that Pixie, the data it collects, provides good baseline level visibility across your cluster. So it's like, you kind of have the common things that you probably want collected. But Pixie, it may be smart, but it's not smart enough to understand what your application is actually trying to do. So, let's say you have a retail application and you want to understand the average number of items that people usually put in their cart before they check out. Pixie isn't able to figure that out for you because it doesn't really know that your application is a retail application. You do want to use other tools to instrument custom metrics that we don't understand. So things like OpenTelemetry, for example, or Prometheus, you still want to use those alongside with Pixie to get the full visibility into your system.
So let's then talk about the user experience. How do you get started using Pixie?
Yeah, so to start collecting data with Pixie, super easy. All you need to do is we offer a bunch of different ways to deploy Pixie to your Kubernetes cluster, whether it's through our CLI or you can deploy Pixie with a Helm chart. You just get Pixie up and running on your cluster, and in less than 5 minutes, we're already collecting a bunch of data for you.
Once you have that data collecting, then we want to access the data. What's that like?
Yeah, so you can access that data using Pixie CLI if you want to, programmatically make calls to Pixie in order to pull that into some other tool or create visualizations. But we also offer a UI which does a lot of that for you, where we have a bunch of different dashboards that, we've written a bunch of scripts for, or the community has written scripts for, in order to visualize that information in useful dashboards that can help you debug what's going on.
So I can install Pixie, I can collect information in less than 5 minutes, I can view that information through dashboards or query it through the CLI. It seems almost like too good to be true. Will you help me understand how it works?
Yeah, so Pixie uses something called eBPF that I'm sure a lot of people are now familiar with, but eBPF allows Pixie to hook into the kernel level in a safe and performant way. And so essentially what Pixie does is it sets a bunch of probe at the kernel level and the user level to basically collect information about, what network requests are flowing through in order to parse that and basically collect metrics for it.
One thing that's interesting is when Pixie starts collecting data, if you're collecting that data at the kernel level, if you're getting all of the data that's coming through the kernel, that's a tremendous amount of data. How is Pixie managing all of that data? Is it taking a lot of storage?
Pixie, what it actually does, because we are collecting so much data, it doesn't really make sense to send that all out somewhere else to store it forever, just because it's just so much. And how much of it is actually going to be useful, right? Most of the time when you're debugging something, there's that one single thing that you actually want in the ocean of all the data that we're collecting. And so what Pixie does is that it stores all of that data in memory, so on the node itself. So Pixie, when you deploy it, deploys a daemon set for each of the nodes in your cluster, and then that data is collected and stored in the pods on each of those nodes.
I have a couple of questions. Sensitivity of data. What about my password, stuff that I want to be secret that Pixie is getting visibility with?
So that's a great point. Because Pixie is using ePF and hooking in at the kernel level, we're actually able to collect traffic before it's even encrypted. And so that does mean that we have a lot of sensitive data that we're potentially collecting. And so because it's stored in memory, it stays in your cluster and it never leaves unless you query and you want to persist it somewhere else. But it just makes sure that your data is kind of kept safe in an area that you yourself control. And that's kind of the nice thing about Pixie's data storage.
So then if I have lots of data and all of my data is being stored across all different nodes, I have a couple of questions again. One question is, how much resources is it using? How long is that data staying on the nodes?
So it's really dependent on your cluster itself. So for example, if you have, thousands or millions of requests occurring in your cluster, we're tracing all of that and collecting something for each of those requests. And so if you're storing all of that in memory, it's probably going to be a lot of memory to store all of it. You can always configure, how much memory you're storing within Pixie itself. But in general, we try to tell people that's Pixie is really only for real-time debugging, because, you don't want to store all that data from a month ago all in memory. That's just going to be so much. And so we like to say that you try to use Pixie for the last 24 hours of data. And usually, for a lot of cases we've been seeing, that's around 2 gigs per each of the data collectors for each node. But yeah, Pixie really is not meant for long-term data storage.
Are there people who do want to save Pixie data for long term?
Yeah, so there's definitely a lot of people, because I think the data that Pixie collects is super useful. And so once they kind of find the piece of data that they really find useful, or they're filtering to something that they find particularly helpful for debugging something, or they just want to store it for historical information, then they're able to send it out, this data out to any other tool that accepts the OpenTelemetry format for persistence or in visualization.
So we have all the data, it's across different nodes. What we talked about, like accessing the data via the CLI or the Pixie dashboards. When I'm accessing the data, do I have to know what node I'm looking at or what node the data is on that I want to see?
No, so Pixie figures all of that out for you. Pixie has a distributed query system. It knows that, you have data distributed across all these nodes. And so when you want to run a query, let's say you want to get all the HTTP requests for this particular service, we have something called the query broker inside of Pixie that understands exactly what data is contained on each node. It will compile that query and know which nodes it needs to send that query to. And so by doing that, you're able to avoid, let's say you have a node of 1,000 clusters. If you really only want data from one node or a few of those nodes, you don't need to go and send that to all 1,000 because it's unnecessary. They don't know what you're trying to ask for. And so Pixie does that all for you under the hood. So to you as the user, it just looks like, I want to run this query. You get that data back. You don't need to know that there's thousands of nodes or how that data is distributed.
And while we're on the subject of that query broker, one thing that you taught me during this longer stream is that queries and Pixies are encrypted end to end. Do you want to talk a little bit about how that works?
Like we said before, because Pixie is able to collect sensitive data, we want to make sure that this data is protected every step of the way. And so whenever you're making a query in Pixie, we make sure that it's end-to-end encrypted. What happens is, just walking through the flow, is you, the user, makes a query through the UI or the CLI. The browser, in the UI's case, will create a public and private key. It will keep its private key. So the private key is only known to the browser itself, and it will make the query alongside, it will pass the public key. And so when the query broker in Vizier receives that query, it will know, like we said before, which nodes it needs to actually send that query to. And when it does, it sends it along with that public key. Those particular nodes will run the query and then encrypt that data with the public key so that if any of the messages were intercepted in between, no one is going to be able to receive your data until it makes its way back out to the browser, who does have the private key. It can decrypt it and then read it. So we want to make sure that the data that we're sending back to you, you, the person who requested it, you're the only person who can actually read it, no matter if there's something nefarious happening on the way.
The last thing we talked about was kind of like the data plane of Pixie and the control plane of Pixie. So the data plane, you said, is made up of a thing called Vizier and another component called Pixie Edge module. Will you talk about those two?
So the data plane is essentially, the part of Pixie that goes and collects that data and executes those queries for you. And that is the part that you're actually running inside your Kubernetes cluster. That's the part that you need to deploy in order to start collecting data. And that's deployed for every cluster that you want to collect data from.
And then we have the control plane of Pixie, which is Pixie Cloud. Tell me about Pixie Cloud.
So Pixie Cloud is something that, you just need to deploy once in your cluster. This is essentially the control plane for managing the metadata of your cluster. So things like, org management, user management, figuring out who can actually see what data and what clusters are connected. This is kind of that layer on top to just give you that nice experience and user interface to, view the dashboards and manage all of those things on top of the data plane.
I have one final question, and that is, where can I go to get started?
Yeah, so we have docs at docs.px.dev. You can go ahead and go there and start trying Pixie out. We also have a GitHub where you can go and dive into the code or start asking questions and contributing to Pixie. And we always love contributors and people getting involved. So yeah, definitely excited to hear from folks in the community.
This has been so much fun. Thank you so much, Michelle, for being a guest and sharing your time and expertise with us today.
Yeah.
Thank you.
Thanks, Whitney. You're an awesome host. So this was great.
Thanks. Bye, everyone.
Thanks, everyone.